Hi everyone, welcome to this next one. So in this one, what we're going to be looking at is area and perimeter of sectors. So you probably want to make sure you're happy with circles and you understand how to find the area and the circumference of a circle, first of all. And if you are, then you can jump straight into this and have a little look at area and perimeter of sectors. But let's quickly recap circles first of all anyway. So area of a circle is pi r squared. And remembering that the radius is just that section there, so it's from the center to the edge of the circle, will give you your radius. And if you are looking for the circumference, so the circumference being all the way around the outside. So in this example, I'd be looking at that. So imagine a piece of string. If you were making a circle with a piece of string, that would be the length of the piece of string would then be the actual outside of the circle. That's your circumference. To find the circumference, you are doing pi times the diameter. Now the diameter is all the way across the circle, remembering that you must pass through the center. That is your diameter, and it effectively is double your radius, okay? So what you're looking for is area, pi r squared, circumference, pi times diameter, remembering that the area is the bit inside and the circumference is a bit around the outside. So if we jump straight in and then look at sectors, remembering that this is now not a whole circle, okay? So what you can think back to is you can think back to having a circle, and if I was to cut it into quarters, okay, that is a quarter of a circle. So if I wanted to find the area of that section, imagine if it was a slice of pizza and I wanted to find the area of that, you could effectively do pi times the radius squared, which would give you the whole circle, and then divide it by 4. That would then give you the area of that purple bit. However, what we could also do, and this is where we're going to link into what we're doing now, is understand that that part there is 90 degrees. So you could call it 90 degrees out of 360, which is the same as a quarter, because 90 over 360 is the same as 9 over 36, which is a quarter. And then you could times that by pi r squared, and that would give you the area of one part like that. Okay, so we're going to use that concept here in what we're looking at. Okay, so your formula to find the area of a sector, and this, if you're making a flashcard or trying to revise, so the area of a sector, the formula you need to know is this theta symbol, which means angle, over 360 times pi times the radius squared. Okay, and if you want to put a note there, that is just angle. Okay, so that's to find the area of the sector. The area would be that grey part there, all of it shaded in. Now, if you were looking to find something what we call the arc length, it links into circumference. Now, the arc length, the way I like to explain this is imagine a pizza again. That's your crust of the pizza. So looking at this, this would be my arc length. And that is done by, same thing again, angle over 360. So always remember that part, times pi, but this time is times the diameter. Because we know that to find the circumference, we do pi times diameter. If I just did pi times diameter, it'd be all the way around the outside. But I only want a small section of that bit, that crust of the pizza you're talking about. So therefore, you only use the angle that you've got. So it's angle over 360 times pi times the diameter. And remember, if this is your radius, you would have to double that to find the diameter. Okay, so they're your two key formulas that you need to have. That one there and that one there. So they're the bits you need to write down, make sure you're happy with. So let's jump in and look at examples of these questions. So this one here says find the area of this sector. Okay, so we know we're going to be using this formula here. This is your very basic example. How it would look would be 52 divided by 360. And remembering, whenever you are typing something into a calculator in an exam, you need to make sure that you write it on the paper so you can get the marks for your working out. So 52 over 360 times pi times the radius, and the radius in this case is 8 radius squared. So on your calculator, you then type in, so I'm going to open up my bracket here on the bottom right hand corner. You can see I'm going to type in 52 and then divided by 360 and then close my bracket times by pi. So depending on if you've got a normal calculator at home or scientific calculator, if you don't, then on Desmos there's a good one you can use, times pi, and then times by the radius, which is 8, and then squared. Okay, now that gives me 29.04227.875. Now, normally in the question it will say to you round your answer to 1 or 2 decimal places, or it will say to you give your answer to a certain number of significant figures. Let's just go 1 decimal place here, making sure that I round it correctly. So that's my first decimal place. What does the 4 do to the 0? Doesn't do anything. So my answer would be 29 centimeters squared. Okay, so that would be your area for this sector. And as I said, the area would be this part inside. Imagine you slice a pizza. It's the effectively the cheese that would cover it. Okay, so now let's look at the next part. It's asking me for perimeter. So perimeter is going to be the outside of the shape. So I need to be careful with this because perimeter is different to arc length. We know, because we're talking about the outside of this circle, I'm going to need to use this formula. Okay, so it's going to be 52 divided by 360 times pi, and then now remembering that this is times by the diameter. This is the radius of 8, so to get the diameter I need to double it, so that is times by 16. Okay, so I'm going to go back over here, and I'm actually going to leave what I've got there, so 52 over 360 times pi, this time times by 16, and that gives me 7.26056 9688. Now I'm keeping that as accurate as I can. In reality, you could probably go 2 decimal places there. 7.26 would be fairly accurate, or 7.261, but let's just keep it like that for now. Now what I've just worked out is this part here. I've worked out the crust of the pizza. Okay, now remember this question is asking for perimeter, and perimeter is not just the crust of the pizza. The perimeter would be that bit plus that bit plus that bit. So therefore I need to add on 8, which is that bit, and add on another 8 to then work out what my answer would be. So then I've got 7.26 plus 16, so 7.26, I'm going to call it 261, and then plus the 16, which is 8 plus 8, and then end up with 23.261. So 23.261, and that would be centimeters, no squared, nothing like that, because this is purely perimeter, and we don't need units that are squared. Okay, so that's how you would use those two formulas. It could just ask you about the arc length. So if it asks you just about the arc length, you don't need to add on the 16. You just work out that bit. If it's asking you for perimeter, then you need to add on the 2 8s as well. So let's look at the next one, which is a bit of an example of working backwards. It tells you that the area is this, and you need to find the perimeter. Now, if you look at this question straight away, there's a piece of information missing from this question, and it's that angle. So when you get a working backwards example in your exams, you need to just write down everything you know. So think to yourself, what do I know and what am I trying to find? Well, this is what I know. I know the area. I know the radius. So thinking about my formula, I've got angle over 360. Don't know the angle, but I do know it's over 360. Times pi times the radius, which is 9.2 squared, will give me the area. And I know now that the area is 53.2. So that's all the information I've been given. What I now need to do is rearrange this to find this part. I'm ignoring this last part of the question at the moment. I'm just working out in this what I can from the missing information. So let's work this out. Angle over 360. Now 9.2 squared, I'm just going to work out over here. So let's just clear the calculator. 9.2 squared gives me 84.64. So effectively, this here, 9.2 squared times by pi is 84.64. And then because you're saying it's that value times by pi, you can just call it 84.64. Pi is equal to 53.2. And that's obviously the area that you're given. What you now need to do is rearrange this. I'm still trying to find this value here. So where it's times by 84.64 pi, I'm going to take that over that side, and I'm going to call it divide. So angle over 360 times by, angle over 360 is now equal to 53.2, and I'm dividing that by 84.64 pi. Let's work that out. So we're saying 53.2 divided by 84.64 pi, and that gives me an answer of 0.2. You can see there are lots of zeros, so I can then say that the angle over 360, so something divided by 360 will end up giving me 0.2000719,039. Okay, the last thing I need to do is, because I'm still trying to find this at the moment, I can get rid of these brackets now. At the moment, it's divide by 360, so I've got to take that 360 over here, and it becomes a times by 360. So you then say your angle is equal to 0.2000719,039 times by 360. And if you do that, so I'm going to keep that on my calculator because I've already worked that out, and then I'm going to put times by. So I'm going to put times by 360, and that gives me an answer of 72.025. Actually, let's call that 0.26 because I'll round it to the third decimal place degrees. And this might ask you to give your answer to the nearest degree, so therefore we're saying that becomes 72 degrees. Now, from here, I'm going to move that out the way to the side. So that's all I'm working out to find the angle. I can now go back to my diagram and I can write 72 degrees on there. Okay. Now I can find the perimeter because I'm just going to follow the steps for what I did here. If you wanted to pause the video at this point and have a go yourself, you can. But I'm going to go through it. So 72 over 360 times by pi, and I'm going to times by the diameter now, which will be 18.4, because remembering that that's 9.2, double it to get the diameter. And that's going to give me, so let's clear this, and we're going to go 72 divided by 360 times by pi and times by 18.4, and I get an answer of 11.561. So that's now the arc length. Remember that crust of the pizza. So that bit is that part there. It's asking me for the perimeter, so I need to just add on those two sides. So I'm going to go 11.561 plus 9.2 plus 9.2. So let's start again. 11.561 plus 9.2 plus 9.2, or you could have just added 18.4, and you get 29.961 centimeters. That would be your perimeter. Now, if that asks you to round that to one decimal place, the 6 would round that up, and actually your answer would become 30 centimeters, which would be your perimeter. Okay, so that's a really nice example of working backwards. Comes up a lot in higher, where they give you the area or they give you the arc length, and you need to work backwards to find the angle or find the radius or find the diameter. So it's worth getting your head around what I've done over here to find the angle first of all, and then I'm following the normal process here to do that. Okay, right, the next bit we're going to end up looking at now is finding the area and perimeter when we're talking about terms of pi, and then we're going to look at some problem solving questions where circles are involved as well. So if we then jump straight in and look at this, let's break it down and look at what we've got. So we've got to find the area and we've got to find the perimeter. Okay, so there's two separate parts to this, and it says here give your answer in terms of pi. Okay, so we're going to need no calculator in this type of question. Now the first thing is we're talking about area, so I'm just going to write out my formula again. Angle over 360 times pi times the radius squared, and that is area. And when we're going to talk about perimeter, I'm going to need to do angle over 360 times pi times the diameter, and that's going to give me the arc length. Okay, and then we're going to need to add the two sides like we did before, add that and add that to then work that one out. So let's have a little look at area first of all. So we're going to go 40 over 360 times pi times 6 squared, and we can work out the area. Okay, now we know that 6 squared is 36, pi is just pi. So instead of writing that as pi 36, what I can actually do now is write it as 36 pi. Okay, so it's exactly the same as doing x times 6 squared, and that'd give you 36x, right? Pi just represents a value, and the value is 3.14159, and it goes on. So 6 squared is 36, and then you just put your pi next to it. Now, what I'm going to do here is I'm going to simplify this. So 40 over 36 can be divided by 10, so it becomes 4 over 36. And then you can divide that again. If you weren't sure, you could divide that by 2, and that becomes 2 over 18. And you could divide that again, which becomes 1 over 9. Or if you're quite good with your multiples, you know that 40 goes into 369 times. So this fraction simplifies to 1 over 9. So what I'm now saying is it's 1/9 times 36 pi, and that will give me the area. Now, to find the fraction of something, so it's 1/9 of 36, you divide by the bottom and times by the top. So 36 divided by 9 is 4. 4 times 1 is just 4. So that becomes 4 pi, and we're going to put centimeters squared. Okay, so the area of that shape, so I want to work out all of this, the area of that sector is 4 pi centimeters squared. Now let's look at the one on the right hand side. So we're doing the same thing, but this one's a little bit harder. So the angle is 40 divided by 360 times pi times the diameter. And remember, the diameter is twice the radius. So it's going to be times 12. Now that bit only gives me the arc length. Now remember that the arc length is like the crust of the pizza. So that's going to be that bit just there. This simplifies again, 4 over 36, that we know is now 1/9. So we're doing 1/9 times 12 pi. Now this is a little bit harder to do because you can't divide 12 by 9. But what you can do is we can just use our normal fractions here. So we're saying 1 over 9 times by 12, which is the same as doing 12 over 1. And that's obviously in terms of pi. So when you're multiplying fractions, you do top times top and bottom times bottom. So that just becomes 12 over 9 pi. Okay, so the arc length of this sector, this bit here, is 12 over 9 pi. That is an improper fraction. What you could also do is go, how many times does 9 go into 12? Well, it goes into it once, and there's 3 left over. And 3 over 9 simplifies to 1/3. So you could call it 1 1/3 of pi as well. So that's the arc length, okay? But remember, we're finding perimeter. So I then need to add on the 6 and add on the 6 because I'm adding this bit and I'm adding this bit. Now, 6 and 6 makes 12. So you're saying it's the arc length, which is 12 over 9 pi plus 12. That would be an acceptable answer. So 12 centimeters. Or you could say it's 1 1/3 of pi plus 12 as well. They are two plausible answers for this question to find the perimeter. So follow your process as we did here, but because this doesn't now divide by 9, we can't simplify that any more than that. If it did, let's say that gave you 18 pi, for example, and then you do 18 divided by 9, which would give you 2, then it'd be 2 pi. Okay, just because it's a fraction doesn't make it any different. The process is still the same, but just remember, you can't do 1 1/3 of pi plus 12, so I couldn't say that it'd end up being 13 1/3 of pi, because that's in terms of pi and that's not, so you can't put your values together. So your final answer would just be either 12 over 9 pi plus 12, that's the perimeter, or 1 1/3 of pi plus 12. So the process is exactly the same as what we did up here. Okay, so for example here I could do 64 pi and then times that by that as well. But all you're doing here is you're just keeping it in terms of pi instead of writing the actual number. Okay, so last one we're going to look at. Let's talk about this last one. So it's a little bit more of a problem solving question. We're going to involve some information about triangles in here as well. This would probably end up being on the higher as opposed to this one being on the foundation. So let's have a little look at what we've got here. O is the center of the circle. That's the middle. So that means that's the radius and that's the radius. It tells you that OA is equal to OB. So these two lines are the same. Okay, we know they're also the same because they're both the radius lines, and two radius lines will be equal. It tells me that OA is 7 centimeters. So that's 7 centimeters, which means that's 7 centimeters. And then we know that OAB is 110 degrees. So that is 110 degrees. Okay, so let's just ignore the fact that it's in a circle for a minute and do this. If I just gave you that as a question and said that was 110 degrees and that was 7 centimeters, you'd follow your same process to find the area as we've been doing. So all I'm doing there is I'm effectively rubbing that out, and I'm just working out all of that. Okay. But the question's asking me to find this. So we're going to talk about that in a second. So the first thing is you find the whole sector. So the whole sector. Okay, I'm going to find the area of the whole sector first, which is going to be 110 over 360. So angle over 360 times pi times 7 squared. So typing this into my calculator. So let's get the fraction button up. So 110 divided by 360, close my bracket, times by pi, times by 7 squared, which would be 49. I could type 49 there, and that gives me 47.0366. Okay, so that is the area of the whole sector. Now, what I'm effectively doing is I'm saying, okay, I'm going to cut off this triangle here, and then if I cut that triangle off, I'll be left with this. Okay, so step 2 will be find the area of the triangle. Now, there's 2 ways you could do this. You could either split it down the middle here, and you could use trigonometry to find the height here, or if you're quite good with your trigonometry and you know to find the area of a triangle, you could say half AB sin C. Now, if you're not 100% sure on that, I'll put a link to that formula and how to use it, when to use it, but that is basically the area of a non-right angle triangle. Okay, so if you've got a non-right angle triangle, you can use half AB sin C. The angle you use is this one here, and that's going to be your sin C. The A and the B are the 2 bits either side of your triangle. So we're going to go half times 7 times 7 times sin 110, 110. Now that will give you the area of the triangle. So let's work that out. So 0.5 times by 7 times 7 times sin 110, close the bracket. That gives me 23.022469. So that's the area of the triangle. Okay. What I'm basically going to do now is I'm going to say I've got the whole thing. So let's just imagine that I've got the whole thing here, which is that purple bit. So imagine all of that, okay, which is 47.0366. And then what I'm now going to do is I'm going to cut off this triangle here, which is what I've worked out in red. If I do that, then I'll just be left with this bit here, which is what I'm looking for. Okay, so effectively you're just doing 47.0366 minus 23.022469. Type that into your calculator. 47.0366 minus 23.022469, and you end up with 24.014131. Now, what I've done there is I've kept that to 4 decimal places, and that one's actually been kept to 1, 2, 3, 4, 5, 6 decimal places. In reality, an answer will probably ask you to give it to 1 or 2 decimal places, but by doing this and this here, it keeps it far more accurate. So I can round this then, and I can say that effectively is 24 centimeters squared. So the shaded bit here is therefore 24 centimeters squared. Tricky bit about that question is you need to first of all identify that that is a sector. If I get rid of this bit here, that becomes a sector. So the whole thing you can work out. And then you need to understand this half AB sin C. As I say, I'll put a link to this in the description, but you need to make sure you're happy and you understand how to do half AB sin C as well. Okay, right, quite a lot of stuff we've gone through there. Just you need to make sure you remember and put down on a flashcard these formulas. You need to remember those for your exam. They will really help you. And then you can either be asked in paper 1. If you're asked in paper 1, it'll ask you to give your answer in terms of pi. If you're asked in paper 2 or 3, it will ask you to give it as a number, and it will give you a certain number of decimal places. Okay, so I hope that helped you. I hope you found it useful, and I'll see you all in the next video.